Find all values of x for which the graph of f is increasing and all values of x for which the graph is decreasing.
So to see if the graph is increasing or decreasing has to do with the first derivative. If the first derivative is positive, it's increasing, right? If it's negative, it's going to be decreasing. What rule are we going to use according to the given information? The exponent does work out, but specifically we're looking at product rule. So let me write this kind of big. Is that negative 2x?
Yes.
Okay. So let's use our product rule to find the derivative. So we have f prime of x. The derivative of the first one is 1 times e to the negative 2x. Plus we keep the first one, deriving the e to the whatever is that itself, times the derivative of the bottom. I mean, not the bottom, of the power, negative 2. So then let's see what is common between these two. We have e to the negative 2x on both of them. So let's factor that out and also set them equal to 0. E to the negative 2x. Oh, don't have enough room. 1 minus 2x. And we know e to anything is always what? This is always positive. Question?
Yeah. Are you just like ignoring the addition sign?
The negative times a positive is a negative.
So it's negative 2x. So the positive, the addition sign becomes.
We're taking out this one.
Mm-hmm.
So I have x and negative 2. Together it's negative 2x.
It becomes 1 plus negative 2x. So 1 minus 2x.
So since I know this one has to always be positive, I'm going to set this one equal to 0. So that means our critical number has to be at x equals, is that 1/2? 1/2? Let's make our number chart. So we have f to f prime, and we're comparing it from 1/2. And I want to find the number that's going to be less than, and notice we have our domain on this one. So I can't pass 10, and I can't go behind, is that 0?
And we just do 0.
So what number can I test between these 2 points?
1/4.
1/4, that works? What number should we test on the right side?
5.
Would we
5?
be allowed to do 0?
It gave us our domain, so I want to kind of limit that on there. Okay, if it did not give it to us, we have all the number to the infinity and negative infinity. Okay? So let's go ahead and plug them in. When I plug in the 1/4, we know first of all this is always a positive. When plug in the 1/4, 1 minus 2 times the 1/4 will still give us what? Positive. And really in the end, we're not really asking for what is that exact number, so just know if it's positive or negative. So if this is positive, my graph is going up. And then when I plug in the 5, we know e to the whatever is always positive. And what's the second component going to give us? Negative. So we know this graph is going down. And I'll write the reasoning on the top. So we know the function is increasing on the intervals of 0 to 1/2. And the reasoning has to be because whatever. And in this case, it's because f prime is what?
Greater than 0.
It is positive, good. Greater than 0 also works. And we know the function is decreasing on the intervals 1/2 to the 10, is it? And that is because f prime is negative. Voila. Okay, our next one. It says to find the absolute minimum and maximum. And notice it says of the graph f. So this time we have to plug it back into the original. So let's make our t-chart. How many numbers are we going to need in our t-chart? The critical point and the 2 endpoints. We need 3 of them. So we have 0. Let's do 1/2 right here just to make it numerical. To 10. And we are going back to the original function. The original function is right here. So it says my x is 0 times e to the power of negative 2 times 0. And we know e to whatever is positive, that positive number times 0 is what? Any number times 0 is? Oh, goodness.
0.
0.
Sorry.
Good job, Robert.
That's okay. All right, for the half, we have 1 half e to the power of negative 2 times 1 half. And if I were to rewrite this, that in the end it's going to make the e to go on the bottom. It's 1 over 2e. Now, is this calculated aloud or not allowed?
Not allowed.
So leave it like that for now, so we can compare it to the next number. So we know the next one says 10 times e to the power of negative 2 times 10. And again, if I were to bring this to the bottom, it's going to be 10 over e to the power of 20. So let's think about the logic behind numbers. As your denominator gets really, really, really big, the actual number gets really big or small. So this is very small. Very small. Then that means 1 over 2e is, for me, just small. So I'm looking for the absolute maximum and the minimum. So looking at the maximum, these are positive numbers, right? So let's write small positive, very small positive. So we know looking at this one has to be the minimum. Is that right?
Yes.
Because 0 is already 0. So absolute minimum is going to be at 0, 0. So that part's good. For the absolute maximum, we have to look for the bigger, smaller number. Which one is that going to be? The half at 1 over 2e. So they're not really asking you to find what is the actual number. So you can kind of gauge in this format. All right, are we ready for number 22?
Yes.
Where can I manage my space? I don't know. We'll figure it out. All right, Ryan, let's read number 22.
Suppose that the function f of the continuous second derivative for all x, and then f of 0 equals 2, f prime of 0 equals negative 3, and f double prime of 0 equals 0. Let g be a function whose derivative is given by g prime of x equals e to the negative 2x times 3 f of x plus 2 f prime of x for all x. Write an equation of the line tangent to the graph of f at the point where x equals 0.
Okay, let's write all the given information kind of big off to the side. F of 0 is equal to 2. And then they gave us, is that f single prime? 0 is negative 3. F double prime is equal, oh goodness, I forgot the parentheses. Of 0 is equal to 0. And the given function I'm going to write over here. G prime of x is equal to, it looks like it says e to the negative 2x. Is that true? E to the negative 2x. And then I have parentheses, 3f of x. Uh-oh. Of course I won't have enough room. Plus 2 times f prime of x. Can y'all confirm that with me? Okay. Do I have enough parentheses? 1, 2, 1, 2. I think I added an extra parentheses here. Silly. There you go. Peekaboo. All right, the first one says to find what kind of line? Tangent line at x equals 0. So we know we need a point. Let's all write out point. The x coordinate is 0. Do I know what the y coordinate is by the given?
Yes.
They gave us at 0, it is
2.
2. And then I need to find out, then what is f prime of 0? Is that also given?
Yes.
Negative 3. So we can do y minus y1, y minus 2 is equal to my slope, negative 3 times x minus 0. Do you have to solve for y on the free response? Just leave it, okay? Go all the way if you feel confident you have enough time, but if you don't, just leave it just like that. All right, for part B, Addison, let's read.
Is there sufficient information to determine whether or not the graph of f has a point of inflection where x equals 0?
So at x equals 0, let's write something. Well, do I have enough information just to say there's a point of inflection? Oh. Who? Y'all remember point of inflection?
Yes.
Can I have it concave up and the next one also concave up? Does it have to alternate? The graph does not have to alternate, okay? It can choose to cave down and continue to cave down, okay? If you remember me calling it saddle point back in unit 1 or 2, that was a long time ago, right? So let's write on here, no. F double prime of 0 being equal to 0 does not mean that F double prime of x changes signs at x equals 0. And always restate the question, all right? More the better. Okay, let's go on to part C, Haley.
Given that g of 0 equals 4, write an equation of the line tangent to the graph of g at the point where x equals 0.
So we have another point at x equals 0. And I need to find out what is our value for the y value. What would I do to find that one? Is that given to us anywhere? For the y value, we have 0, 4. And then I have oh, they gave us the 4. Silly. I was trying to find the y. Okay, let's find the slope. Our slope on this one would be g prime of 0. And to find the g prime of 0, we would have to plug it in to our function right here. And I would use this function right here. So I have e to the power of negative 2 times 0. Then I have 3 times f of 0 plus 2 times f prime of 0. And those information are actually given to us. Isn't f of 0 already given to us as 2?
Yes.
Is f prime of 0 also given to us as some number?
Yes.
Yep. And we know e to the power of 0 has to give me what number? 1. So let's write out 1 times 3 times 2 plus 2 times the negative 3. And what would that give us in the end?
0.
0. So let's write out our equation. And it's our tangent line. So y minus 4 is equal to the 0 slope. X minus the 0. And leave it just like that. Yeah. How's that? All right. Are we ready for the last part? Oh, how am I going to fit it in? Edith, go ahead and read part D while I think.
Show that g double prime of x equals, do I need to read it out? E to the power of negative 2x times negative 6 f of x minus derivative of f of x plus 2. Let's say 2, is that double?
My name is not on that word problem. Come
I
on,
know,
girl.
is it double prime now?
I think it is.
2 double prime of x. Does g have a local maximum at x equals 0? Justify your answer.
All right, so here's something unique about this problem. It's saying show that is a double prime, meaning they're testing to see from single prime, can you take the derivative, okay? So we have to make sure it looks like this in the end. So, let's start by writing out the original equation from the very top. And we'll take the derivative of this. Okay. Okay, what rule are we going to use on this one? Product, we have x over here and all that component. So our product rule says for g double prime, we derive the first one, which is e to the negative 2x times a 2, or negative 2. And we keep the second one as it is. Quite tedious, but all you have to do is copy what's right above. Oh, of course, don't have enough room. Plus, then I'm going to keep the first one, which is e to the negative 2x. And let's go ahead and derive the second one. My second one is 3 times f prime of x plus 2 times f double prime of x, because it is a derivative of the original. Everyone good with that?
Yes.
So now what we're going to do is we are going to distribute. So we're going to take everything outside of this parentheses and give it to the first one and then second one. And my second component as well. I know it's going to look quite messy. So let's go all the way over. Well, let's see how I want to write this. G double prime of x is equal to, because I know I have to multiply the negative 2 and the whole number 3, I see negative 6, e to the negative 2x, f of x. The next one, what two whole numbers am I going to multiply by? This negative 2 and this 2. So we have minus 4, e to the negative 2x times f prime of x. That was the first part. On my second line, let's go ahead and distribute. So I have plus, I see 3 as the whole number, e to the negative 2x, f prime of x. I might actually make it. This is amazing. Plus, I see my 2, e to the negative 2x, f double prime of x. I'm so proud.
Just a little messy.
Hmm? Be nice. Okay, whatever. Now let's see what two components I can go ahead and combine. Do we see that we have e to the negative 2x, f prime of x on both of them? So can I go in and combine like terms with the coefficient right here? Yeah, let's do that. So I have is equal to, and let's see if there's anything else. Nope, just that one. Keep the first one as it is. Combine the middle term, which becomes negative 1. And then we have the last part. So we combine the middle. Now when we look at this, let's see what is common all the way through. What can I factor out from the 3 components right here? Good, they all have e to the negative 2x. So let's go ahead and pull that one out. So I have e to the negative 2x and put everything back. And once I factor out e to the negative 2x, let's go back to the original question. Is that what they wanted? Do we see exactly what they wanted? Yep, so we're happy right here. So what they're actually grading is everything in between. So line 1, line 2, and line 3. All right, let's see if we can maybe use this room for the next piece. All right, the last piece says, does G have a local maximum at x equals 0? So let's figure that part out. The first thing I'm going to do is figure out when G prime is equal to 0, because when f prime is 0, there's a maximum or a minimum. And after that, I want to figure out double prime is a 0, then we could figure out if it's concave up or concave down, okay? So let's write on here G prime of 0. I should move it over. Oh no, it won't zoom out anymore. Well, oops. Okay, G prime of 0. Didn't we already solve for G prime of 0 previously right here? So if I were to take what I did right here, at G prime of 0, it was equal to 0. What that basically means, there may be a minimum or there may be a maximum. That's one or the other. So we're narrowing this down. Now we need to figure out, well then at G double prime of 0, what number will that give us? And for us to figure that out, we would have to plug it in to our final equation down here. So let's do that real quick. So we have e to the power of 0 times negative 6 f of 0. So again, I'm simply plugging 0 into my x. And then we have minus f prime of 0 plus 2 times f double prime of 0. The first one is going to give me 1. Is everyone good with that? 1. Then I see negative 6. Wasn't f of 0 given to us already? F of 0 is 2. Minus, wasn't f prime of 0 also given? So I'm going to say double negative is plus 3. Are we good with that one? I see some people just staring and not writing. Good luck to you. And then I got that one and that one. Plus 2 times f double prime of 0 is also given to us. How many? 0. So really in the end, we're computing negative 12 plus 3. How many is negative 12 plus 3? All right, so negative 9. So we know f double prime is negative 9. And if it is a negative number, is it concave up or down? It's concave down. So is it a local minimum or a maximum? Maximum. So let's write the reasoning, because your justification is part of the process and the way it's graded. G has a local maximum at x equals 0 because of the following reasons, and we have 2 of them. Because g prime of 0 is equal to 0, and specifically g double prime is, of 0 is negative.
Is that 2G double prime?
G single prime and G double prime. Oh, and.
And, that's the and sign.
How do y'all do your and sign?
Like that.
Is that it? Like this way? This is my and though. They look alike, right?